Hello, everyone, and welcome to today's Tech Talk on Fire Life Safety System Commissioning. My name is Sherry Adams, and I'll be the moderator for today's presentation. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. We'll be using the Q&A function for questions. So when you have a question, you can send it through the Q&A function in the control panel. We'll gather these questions throughout the Tech Talk and leave time at the end for Q&A. If you have a question related to a particular slide, please include the number of that slide in your question. A PDF of the slides of this presentation will be sent electronically to all those who have registered for today's Tech Talk. We will also be recording it, and it'll be available on our website under the resource section. Today's presenter is John Herboth. John is a senior commissioning project manager at Northwest Engineering Services, Inc., with over 13 years of experience in building, commissioning, and healthcare facilities. He believes that sharing project successes, failures, and best practices is a professional duty. John is also a board member of the Northwest chapter of the BCA. And with that, John, I will hand this over to you.
Thanks, Sherry. Well, we'll just get started from the very beginning, make sure you can see everything. Today, I'm going to be talking about commissioning fire life safety systems, specifically tie-in to HVAC systems, some of the components like FSDs at critical healthcare facilities. And then what happens there is that there's going to be some aspects I'm going to discuss on the coordination efforts. We all know in an active hospital, it's definitely a lot harder to do your job in a remodel situation. And even when it comes to new construction, it's one of those aspects they want to get started as soon as possible. So for FSD testing, in a hospital, it's about every 6 years for testing, and for all other facilities, it's supposed to be 4 years. So this presentation is primarily going to focus on some of those lessons learned from some of the projects I've done recently in a hospital environment and also other medical office buildings. So my hope today is to help you learn a few changes that have happened in enforcement recently for healthcare facilities, understand why these devices need to be tested regularly, identify some lessons learned, and then some best practices. Just a little background for me. I started my first FSD testing project back in 2008. And it's one of those scenarios where it was a very big hospital down in Salem, eight stories with the basement. And then that was also my first commissioning project on a large building. And there was 850 fire smoke dampers that had to be identified and tested, and smoke zones, different pressurization issues, and just the way it was coordinated. It was a very complex project to gnash your teeth on to start. We didn't do much testing over the last, 6 years after that. So from about 2009 through about 2015, 16. And then it started to ramp up again as HJs have been going higher on the enforcement for not just hospitals, but the medical office buildings all the way down to rehab centers and assisted living. So that's one of the aspects that where a changing environment has really put a call out there for more people to test, identify, and go through and commission systems. Some of them that haven't been touched since they were built. A lot of those calls go to the fire alarm providers for those existing buildings, and then it's just not something that they test. They'll go through and check all their systems connected to the fire alarm control panel, but they don't go and inspect everything and visually confirm that all those dampers are working. And so they'll usually make a call out to somebody else. And so I've gotten a lot of those calls. For meeting some of the HJ requirements, you gotta know what, it comes down to like 4 basic things. Know what you have, get it tested, know what needs to get fixed, and have a plan to correct it. And so that's where we can come in and help as commissioning providers. This is another code pull out from Chapter 7 for International Building Code and Chapter 9. You're going to see this in multiple states for fire code as a reference point, and also NFPA 80 and 105. So take a look at what your fire code is for your state or your city, and you'll often see references to NFP 80 and 105, and that just reinforces the 4 and 6 year damper testing. And for a lot of that stuff, you know, again, it comes down to enforcement. You should be doing this for schools, tall commercial building, any building honestly in the commercial construction. They should be obligated to do it. It's just enforcement's not there. And so what has happened is fire marshals and even federal surveyors have put a focus on places with high occupancy. So you're going to see it in schools, auditoriums, and now it's down to even assisted living, where it's really important that those fire rated walls and assemblies and components function correctly to give people the most time to evacuate safely. We're all great at spreadsheets. This is an example. You end up putting in a lot of detail. If you get lucky and have good drawings, then you end up having a lot of detail for everything down to what electrical circuit the fire alarm relay is on and what the FSD is powered through. And the one important thing that you're going to want to do if you ever find yourself doing one of these projects is get your details down to the point where you do all the work to make sure that happens the first time right, and then somebody else could follow you up pretty darn easily. You know, everything down to the size of the ladder you use to access it, because access tends to be one of the most challenging aspects of testing. I will show you plenty of pictures of why that is. I'm sure you guys have seen some pretty hairy stuff out in the field. You obviously will even run into some stuff that you've never seen before. This is on the right is a fusible link to a fire damper, but it also has, looks like an element to it that will provide some sort of notification to a building automation system. I can't be absolutely sure on this one. I had to pull this from a coworker. I don't think he remembered either, but you'll run into unique stuff and you'll have to identify what it is. There's not a lot of uniformity when you come into some of this stuff. And that's one of your goals is to provide that uniform documentation of what's actually out in the field. Sometimes your access is great. I can fit my whole body through one of those access hatches. You always want to have a guy on your team that's thin and tall, hopefully, and definitely long arms help as well. Then sometimes you run into some new stuff. This is actually a volume adjustable fusible link, and it can help set it for returns for flows. But testing some of these is very difficult. Taking it apart and being able to actuate it has its challenges. And then you'll get into some dampers that and their actuators that are actually need to be replaced no matter what, if they work or not. This type right here is on a recall for fusing the gears inside due to the electrical issue. And then sometimes they're nicely coated. You have to replace that fusible link and maybe even some of the assembly if it gets too gummed up and it doesn't end up working. And I'll get to my first project. This was at an existing hospital here in the Portland area. And what they were trying to do on one of these projects is reduce the amount of FSDs that they had in the field and the amount of fire dampers. So what ends up happening is they have to get a fire protection engineer and someone who's familiar with the building and really go through all the smoke compartments and fire compartments and start taking a look at where they can start reducing that to meet current code. Because if they do one of these type of projects, you run into a scenario where you have to meet current code in regards to compartmentalization. So it could be a good thing. And if you get unlucky, some areas you might even have to add some. The biggest thing for hospitals ends up being coordination. In an active hospital, you can't shut down equipment without some advanced notification and coordination of who that impacts. So the drawings end up being really critical for you tracking down each duct. And that's what's written on the document, not what's actually out in the field. So you can do your best coordination and you can find some side impacts that are going to really be troublesome. But you end up trying to take a look at airflow quantities, making sure that when you're testing these individual fire dampers or fire smoke dampers, that you don't shut down a piece of equipment due to high static or low static. problems. And so you start taking a look at the duct sizes. I tend to take a look, as you can see in one of the columns that I have them in red, for the ones that are getting a little bit large. My rule of thumb is, 4 square feet and above. So that 24 by 24 is when you start saying, hey, we should start taking a look at airflow through this to make sure that we don't impact systems. Obviously, the higher risk goes to ORs and places where the occupants have more critical nature spaces and services. Let's keep going. What aspect that you're going to end up finding that you really need to start learning in these areas at a hospital specifically, and once you get into other places like any high occupancy building, that the fire damper relays that control and connect to the fire alarm system, that they need to be inspected to make sure that they are labeled correctly and landed correctly. One of the problems that we ran into in this hospital was we went to go testing. We did all this coordination to make sure that stuff shut down correctly and closed. And we found stuff didn't close or it didn't respond at all. And so there's going to be some wiring issues that you're going to run into, that you're going to need an electrician with you at the time, as well as the fire alarm contractor if it was a programming issue. And then you yourself have to be documenting this entire time and coordinating the effort. So you need a minimum of 3 people there running the scenario, and then also taking a look at the HVAC systems to make sure you haven't impacted any other systems. So it tends to be a 3 to 4 person job at night to work on some of this stuff. And you can't figure it out until you test it. And you can take a look at the wiring, you can take a look at a bunch of stuff and have the contractors give you pictures of every single relay to make sure it's wired up correctly. But you might not be able to pick it up on the program side until it's done. Let's see, I got a question coming in here. Did your commissioning of a fire life and safety system utilize only ANSI approved process containing FPA 33 and NFPA 4, integrated testing of fire protection? So I've gone through and done NFPA 3 and 4, but in this circumstance, on this project, no, we weren't using that as the baseline. But those processes are, they're standardized to help you go through and do this type of stuff. So I've definitely used that as sort of my baseline, sort of like your engineering degree, use that as your baseline. But I didn't go step by step using that as my backbone, basically. Now let's keep rolling. Let's see, and then we also had some problems with some EF equipment shutting down and working correctly. So smoke evacuation ends up being another critical part of the commissioning side. And the functional test, you can't replicate it. You have to go through and be able to shut it down. And so one thing you tend to lean on is using the fire alarm contractor to set up programmed buttons to test specific relays to trigger it, so that you don't have to go out in the field and smoke a head or smoke a duct detector, because you don't, especially in an older hospital that's had many remodels, the programming ends up being, you try to find what's connected to what relay, and the documentation just isn't there for you to make sure and validate that you're not going to impact something else. And it all comes down to the identification and how it's been named and naming conventions in the programming for a fire alarm contractor to do that. So you'll have much better luck with a new project, obviously, is because everything is fresh. But on an existing hospital that's had so many remodels, you end up having some problems just from the method of testing. So that is one issue that you're going to have to tackle on each individual project. It's hard to go through and not impact other systems. You're going to, and so you try to reduce it. And then some of those test methods might create their own problems at the same time. Let's see. This is an example. This is from a Kaiser project, some of the programming that you see. And what's going to end up happening is if you can read on the output labels here on the left, and the input labels, you'll see equipment type, what device type it is, and then potentially that there's FSD relays going to the Ansel system, the radiology. And so those are labeled really well, but you're not always going to come into that. And you're going to come into ones that are just labeled FSD. And that's where you have the biggest problems, is that when it's not descriptive enough to tell you what's connected to it. And then there's also the problem when you have addressable components that they get added on to a relay because of the nearest addressable component. And if they don't do that right, sometimes on the wiring side, you can start impacting it as well, even if it can be picked out individually in the program. Drawings for fire alarm aren't something that I know that I initially looked at as commissioning provider very closely, and now I look much closer at it, specifically that they've identified where those relays are located, which is often near an electrical panel, and usually just outside of them, but sometimes not. So those end up being really important in a hospital level, especially, or any other building where the testing can get complicated because of what they do. And popping your head above every ceiling tile is just generally not great. There was a couple that we had to test on that project where the electrician traced 150, 250 feet and couldn't figure out where it went, and that's a problem. They later found out. It took them just a week or two to find it, though, and that's just a lot of time. Here's another project that I'm going to use as an example. It's a medical building attached to the hospital. This is another scenario where there were two tenants, the owner and the tenant, and the hospital was sharing the second floor and I think a part of another floor on the medical office building where they were still doing ORs. And the problem that ends up coming there is now you have a mixed use building, and if you don't have dedicated systems to that whole area, a fire alarm could impact, a potential critical area. And they're not always, sure of how it gets impacted unless somebody really did thorough testing. There was no testing records at this building for this example. So we went through and we had a high rate of failure on this building. 38% failure rate on the FSDs is terrible. Groups of failed FSDs, so that typically points to a relay issue potentially when there's a group of FSDs not working, or a programming issue. And then on top of that, the air handlers didn't shut down. And lo and behold, later on, you find out that there was a DDC upgrade, and the DDC was originally the ones shutting down the equipment, or you find out some other scenario where wiring was pulled off of a VFD, and that was supposed to provide the shutdown command. And there was no smoke vent sequences on a floor which had ORs. They weren't, they were day surgeries, but another scenario where you run into a place that has, operating rooms that will shut down all their HVAC equipment if a fire detector gets triggered anywhere on that floor. And this is an example here of some old fire alarm drawings, which showed relay locations, which was great. And they were accurate, and you feel lucky when you run into this situation on an old building. And you even had points lists written down by hand on the drawings. It was great to look through some of the older detail that somebody put into it. And here is an example here where you start looking at the control ZAM relays, and they're labeled, M196, and where it's located and what's controlling. But this is an example here. It says dampers, ground control elevator. That's really descriptive. Damper control per hall, G202. And that's just not very descriptive. It's descriptive for location, but not for what other dampers get triggered with that. So descriptions are really going to be critical in the programming to help you out in the field. Otherwise, you spend your time just triggering every single relay you can with a fire alarm contractor and going through and documenting the results. And that's a lot of field time. So here's one that controls AM here for that same project. And, you start taking a look at the drawings, normally NC normally closed, NO for normally open. So you start taking a look at the contacts is where you are end up going to spend some time out in the field if you run into a problem. And for all these FSDs, unless it's involved in smoke ventilation, they should be normally closed. So they power open and normally close. Some big air handlers on the top, that's what you're seeing right here. And then inside of it were some landings from the fire alarm system, but nothing was shutting down. So on an older system like this, an older VFD, you have to get a rep out to take a look at it because, as often as we look through VFD settings and know our way around quite a few different controllers, this was one of them that I had no clue what was going on here. All I know is it wasn't working. And sometimes you get somebody to show you how to take some of these panels off, and then you have some pretty good access. You're going to run into some hidden FSDs sometimes, or later on you're going to find more because of that same scenario where, documentation wasn't great and you can pop your head above the ceiling numerous times, but you won't find everything. So it's definitely a living document whenever you do FSD testing and fire life safety commissioning. This is another project that we have right here. This was a medical office building, again, with surgery spaces as well, but not just day surgeries, but some more complicated surgeries. And this had wonderful CAD colored drawings. It's one of those that you like to show off a little bit, even though you didn't do it, and trace everything out. And it ended up being very accurate. But it's one of those that it's another mixed use building. There's more HVAC smoke control sequences, but we had a 14% failure rate on a building that had some critical ORs in it. And that is a problem. It's normal to see failure rates 10% and lower that I've experienced. But once you get to the 15, 20, 25, that's just really high. These motors fail. They either need to be cycled more often, says the manufacturer, or you cycle them too often and they fail. The problem ends up being too is the amount of play in the damper assembly, whether at the very end it's torquing down and causing some wear on that motor and assembly. And so these dampers, even with new ones, that say they have 1 million cycles or 500,000 cycles, that these motors just fail. And it might be just the product quality, but this is the whole reason they have to get tested. And it's the problem that you're going to run into on a lot of these buildings, whether it's a hospital, which is usually had testing done, or a medical office with some surgery that hasn't had testing in a decade or two, or you get down to a rehab center and assisted living that's never had its ducts, even inspected since 1980 or 70 or 60. So you're going to have a wide range of complications when you start going through testing. And, I've spent, weeks in an attic before, crawling around through insulation with 2 of my coworkers, just trying to find everything. The assisted living rehab side of stuff, where the construction quality is definitely a lot lower and the documentation is a lot lower, you end up spending an abundant amount of time, crawling around between joists and trying to get to every single device that probably had never had any intention on the installer side to be accessed later. And that's where we come in and make sure that, they understand what it takes to get to there. And if I can't get to it, I have my doubts if it can ever get gotten to. So access is king on some of those projects. And some of them, honestly, you'll never be able to get to. I've gone into a brand new building, and there was an FSD 16, 18 feet, you know, above a drop-in ceiling in an entrance area, or in near an elevator area with high ceilings. And then even above that, you know, that it's just so far up there, it's just not practical. And so if you ever run into a situation on the install side or in the design side to avoid that, I mean, by all means, you have to. It's just not practical to have to open up an entire T-bar section, bring in a lift, go up, and then you're running into piping, and then you're like, what, am I supposed to now put an extension ladder up, you know, 40, 30 feet? It's really difficult to justify that on the design side. So that's one aspect that I really tried to take a look at, no matter what building I'm reviewing. You'll typically see one of these drawings where it shows a fire alarm matrix showing when is it supposed to close down, when an elevator is supposed to recall. This is one aspect when you commission fire life safety systems that you want very well detailed. And then specifically, if there is any differences between air handlers, that those are noted in the remarks, so that this is very generalized here on the screen, but it can also get much more detailed if you take a look and ask that to get more detailed. And then you're going to get lucky sometimes in the field with smoke vent sequences that are easy to identify with inputs and outputs for what systems they shut down. This is definitely the ideal on that right picture, where you could easily, with a little directions, operate the fire alarm panel and make sure to put everything in the right mode of operation to confirm it. I think I spend the most time I feel wasted in the field when we're commissioning these and functionally testing them, that when you can't get something to close because your priority just isn't high enough, whether you just can't get the system to react appropriately, and you find yourself wasting a whole night because you don't know how to control a fire alarm panel. And that's where you really have to get everything sort of walked through with a fire alarm contractor, especially if they're not going to be there, to make sure that you're effective from the moment you get in the field. Let's see, we'll keep going. I have another project here. This was a fun one here. This was a 1960s hospital in Washington with a brand new addition in that bottom left curved wing area, and a traditional sort of cross style hospital with 4 wings, and then an ER department to the lower right. And going through these drawings and finding stuff, I think the hardest part about an FSD project in general, where you don't have good documentation and you're the one finding that information, is setting those expectations that we're going to start looking and you thought you had 20 dampers and we're going to find 200. That was an extremely hard discussion over a course of months with this client. And I can't tell you guys enough, if you find yourself in this situation where you're doing the investigation side to find out how many devices are in the field, that you have set up the expectation that you are likely going to find more. It's just what happens. So on a T&M basis, you guys are going to be like, okay, our scope is to find 30. We can test 30 under that. But if we start finding more, I'm going to let you know immediately. And I'm going to let you know if we can cover that extra 5, or if it's an extra 20 that we can't cover it. That's the one great thing about being a commissioning provider, where you try to be diplomatic in a situation to set your expectations, and then to say what you can and can't do with that time. Because if access gets really hairy, it's going to be really difficult to even justify getting to that initial 30 if you just can't get to it. I think this one had a 32% failure rate. It was just huge. And that's mostly, the high failure rate is especially troublesome when they're fire dampers, because they all need to get replaced. And it's very expensive to replace those versus swapping out a motor, which can be usually pretty easy. Some of the common stuff that you run into, I'm sure you guys have your own horror stories out there, where cables and cords running through fire-rated access hatches, through a duct, and then out another access hatch on the opposite side of a firewall. You know, stuff not being tied into a fire alarm system, finding them failed open. If you find a failed open device, then you have to start confirming whether or not it's got power or ever depowered, because the motor can sometimes it doesn't have the spring return, just is the part that failed. And so you really have to go in there and use your electrical knowledge to start taking a look at, is it the relay the problem, the device the problem, and then what part of the device? And those type of notes are really important for you to be useful to another contractor coming in and replacing and fixing work. We try not to just identify that we have a problem. You want to know exactly what the problem is. And if you're already crawled up 20 feet down and, you know, into this tight spot, you know, a picture is of every device that you run into is going to help so much. Some of these more critical projects, we use a photo log, and because they don't know what they have in the field. So we take a picture literally of everything up there. And then for your own safety in a major hospital, you're going to want to take a picture with it closed, fully closed and sealed. And then you're going to want to take a picture of it fully open, so that that's the way you left it. So after the system was reset, that takes time, but in an active hospital situation or a critical area that's served, you want to make sure that the system is back to normal, and that you, being the last person who activated a device, made sure that it's back in full operation when you leave. We also found some problems with FDs that failed to close completely. That's very common with these sort of flat coil springs that I'll show you guys. And they just don't have enough tension on them to pull it closed. And then you'll run into FDs that are non-replaceable parts, and like this one right here, where to test the device, you have to destroy it, you know? And so this little cartridge in the center is one where that's what melts and then it releases. And there's no easy way to sort of pull it out like a little clip. And so we had to completely disassemble them, actuate it. And then because that fusible link is, we had no identification on it, had to put it back in, assuming that it would work. And so you can test a few where they can easily get to it and replace, you know, say a 4x4 or 4x8 fusible damper, just to make sure that they're working and what temperature that they melt at. You're going to run into about 165 is the most standard, and 212 is the other standard. And I'm actually not quite sure when you would use a 212 application unless it's in some sort of high temp location. Let's keep going. So these were fun. You're allowed to reuse fusible links by code, as long as you can inspect them and make sure they haven't been damaged in any way. So if they're coated with anything, you have to replace them. If you can't inspect it, then it's got to be replaced. So as long as you service everything, you can reinstall it. You just want to note that in your table. And one of the last things I come to is safety is going to be a problem. This is an open shaft here and a little metal platform. And somebody gets to go test this stuff, and you can be harnessed, sure. But in some of these situations, how are you going to recover that person is just improbable that you're going to spend the time for two sets of dampers to come and use this platform. And in this situation, we had them cut new access hatches on the right so that we wouldn't have to enter the shaft to facilitate testing these dampers. But you're going to run into your own crew too, going through places that could have asbestos. You can run into situations where you need to know whether or not you're putting your guys at risk, whether that's their lung health or their bodily health, because of it's it's hard work. It's hard on the hands and the ligaments to go in, especially doing stuff one-handed. You'll have to develop a little hand tool list that ends up giving you that edge to go through and test, 25 to 50 dampers in one day for fusible links that are one-handed. So if anybody has any questions about project safety, feel free to let me know, because you're going to be in some situations that you got to keep your guys rested and make sure that they have a sustainable pace, because it's really hard. You can estimate it takes about 10 to 15 minutes for a fire smoke damper, but it could take up to 45 minutes for one fusible link if it's in a hairy situation. And it's really hard to quote those type of projects, and that's why setting expectations is so critical. Sherry, I'm wrapping up here. Oh, we got one coming in here. Let's take a look. Should the BCA advocate for better documentation and labeling of fire smoke damper devices to reduce the many problems mentioned before certificates of occupancy are issued? Should the BCA advocate for standards to facilitate 4 to 6 year testing, including safe accessibility to test? I mean, as a commissioning provider, yes, you should be advocating for that, but the BCA, it can be one of those scenarios where we support what's already a guideline for labeling. And so the NFPA that go in there tell you the devices need to be labeled and access needs to be there. But advocating for a standard to safely accessibly, get to those devices ends up coming down to the person that tests it initially. I've come into a few situations where we went through somebody's previous testing documentation and we don't know how they tested a device that we found. And my answer to that ends up being that, yeah, we should advocate for it. I don't know if the BCA is in a position to best do that, but your local fire protection engineering association might be a better route, because they actually have people on some of those NFPA and protection code committees. Any other questions?
Thank you. Oh, John.
There they go.
A few more questions are coming in. I was just going to say, everybody, we have a few more minutes left, so I'll let you take it away again, John.
All right, here I got another one. Are we as CX providers eligible to verify fire safety system installations and implement functional performance tests? Or are we first looking for an authorization to follow the commissioning installation and then witness the testing by the authorization or contract and verify the completion of the fire protection testing? So you're going to run into a few situations out there, and we were actually, as a chapter, the Northwest chapter, was going to have our conference with an actual fire life safety system, HJ, basically. So there's a lot of aspects that as CX providers that we can do and test, specifically with what we're qualified to do. You're going to want to take a look at some of the qualifications required in your state or city. A lot of them call out to be a professional engineer, testing and balancing engineer or certified, and then others with NICET, NICET certification. There is definitely, it really depends on what project that you're working on that you have to find out whether or not you're eligible to verify that system, because you can go into some project documents and find out that it's got to be, the qualifications there are listed, not only what's required in your state, but there are additional qualifications. You come into a bigger building, you're definitely going to have the experience of testing the system on a regular basis and not on a 10 to 15% of your yearly functional testing is done. It becomes very specialized, and I'm not recommending that everybody who's a commissioning provider go out and say that they're specialized when they're actually, they don't do enough to stay current with all the requirements. And then I have another question here. how are you tripping the smoke detectors? Pulling the wire, test switch, or using smoke? So in a lot of situations, we used to use a test magnet. You're not supposed to do that anymore to do a functional performance test. You're allowed to do that to do some pre-testing, but we end up smoking a lot of devices and to get the first time testing done. And in an existing building, you can go back to using a magnet unless it's on an actual annual inspection, and then they'll do a smoke again. So if you're testing it and it's not part of an HJ coming in and doing their annual, then you can use a magnet. But when it's an annual or the first time functional performance with a fire marshal, then you have to use smoke. We typically do not pull wires. We try to do we try not to simulate it unless we have to. But that does mean you have to bring some extra smoke detectors with you in case you mess a device up. So definitely have your fire alarm contractor have some extra heads to bring along with you. And then I have another question here. Any recent stories about loss or life of property due to inoperable fire smoke damper systems that could have been prevented by CX or the 4 or 6 year testing? I personally don't have any. The story I tend to use the most is I went to an assisted living facility that had 3 separate buildings, and 1 was newer and 2 were older, and they recently did a fire alarm panel upgrade. And we ran into the situation where I was testing the first building, everything was working great because it was a newer building. Yeah, some access wasn't great, some dampers were working, and then the other 2 buildings, nothing closed. So you had a building with 400 to 500 occupants that really need help getting out of the building, and no loss of life because no event happened, but they definitely had to go on fire watch immediately. And that was definitely a situation where you pull them aside, like, hey, this is a serious problem. Just like that one building that I was talking about earlier where the air handlers didn't shut down. This is a major problem that we need to address now, and we have to notify your fire marshal that we're addressing it, but we're going to need their involvement until we get it fixed, because you're going to run into an ethical situation, even if there wasn't actually any loss of life. There is the potential of that. Let's see, we got one more. When you do testing in smoke control systems, do you normally just test the normal, let's see, where is it? Do you normally just test the normal conditions, or do you also test the smoke control system in fault conditions? How do you verify all the various points in the fire alarm system that trip the smoke control system? So smoke control systems, I'm about to do another one in March of this next year. Where you have to, this is part of being a fire alarm, commissioning agent. And you approach the aspect where you have to test those as a requirement. You have to test whether or not it's done at the fire alarm or fireman panel with the override controls to a whole system, and all those devices are connected to it, and then you have to test whether a switch out in the field fails. Those requirements, if you are doing a certification, you do have to test every single aspect of it and every single failure type as a requirement, and not just say a sample that is part of your commissioning scope. So we verify everything that you're required to verify, and then in what's typical for commissioning is, you do a sample, and you just can't do that if you're the one certifying it. Let's see. So we'll test everything. I mean, you have to. See, I got one more here. Is the fire safety testing part of the building integration system testing, BIST, in addition to M&E, M-A-E, functional performance test completion, or due to blackout power, could fire alarming be done during a building integration system test. So I'm a little confused at what you're trying to get out there. Can I get a little follow-up with this person? With Amir? Sherry?
Sorry. Yeah, by asking, he doesn't look like he's added anything more to his question, so we'll keep an eye out here for it.
I would be happy to follow up on this one. But one of the aspects of testing is that you assume that there's been a power failure. And for a more critical site like a hospital, they usually have automatic transfer switches and bringing up from different substations if we're talking about source power, or we're talking about power to a fire alarm control panel. Obviously, if you lose power to a control panel itself, the brains of operation is down and you can't really do that testing. So I'd just like a little bit more detail from them, and I'll follow up and answer it.
That sounds great. We'll get that answered for him. Well, thank you, John. We really appreciate your time and expertise. And just as a reminder to everyone out there, the BCA Social Hour is scheduled for this Wednesday, November 18th at 1:30 Pacific time. You should have received an email about it to register, but you could also do so by going to our homepage on the BCA website. And there's also a final webinar from our fall series scheduled for December 14th. It will be a panel discussion with the 3 presenters from the series. They'll review planning, contracting, and commissioning of lighting, security, and fire alarm systems, focusing on integration with all the associated building systems, and share their lessons learned. So on behalf of the BCA, I'd like to thank everyone for your participation today, and have a great day.
Thank you, everyone. Have a good one.
Thanks, John.